Good morning, everyone. Let us see projectile in inclined plane. In our previous class, we have seen definition of projectile motion in inclined plane and range and inclined plane. I am Dr. V.P. Anuja, Associate Professor, Department of Mathematics, Arulmigu Palaniyandavar Arts College for Women, Chinnakkalampur, Palani. For better understanding of inclined plane, today let's look into an example. In this question, for a particle in projectile, the velocity of projection of range down an inclined plane to its range up the inclined plane whose inclination is alpha is in the ratio 1 plus sine alpha by 1 minus sine alpha. Here, let u be the velocity of projection and theta be the inclination of the direction of projection with the plane. The velocity u can be resolved into two components, u cos theta along the upward inclined plane and u sin theta perpendicular to the inclined plane. The acceleration g can be resolved into two components, g sin alpha along the downward inclined plane and g cos alpha perpendicular to the inclined plane. Consider the motion perpendicular to the inclined plane. Let t be the time of flight. Distance traveled perpendicular to the inclined plane in time t is equal to 0. By using the formula S is equal to ut plus half at square. Now let's substitute the values of u and a in this equation. Here u is equal to u sin theta and a is equal to minus g cos alpha. By solving this equation, we will get the time of flight is equal to 2u sin theta by g cos alpha. Let's substitute the time of flight value in equation 1. During this time, the distance traveled along the plane is equal to u cos theta into t minus half g sin alpha into t square. Let us take 2u square sin theta by g cos square alpha as common. The remaining terms are cos alpha cos theta minus sin alpha sin theta. As we all know, cos alpha cos theta minus sin alpha sin theta is equal to cos of theta plus alpha. Let us take 2 cos of theta plus alpha into sin theta, which gives us sin of 2 theta plus alpha minus sin alpha. This is the range R1 up the inclined plane. R1 is maximum when sin of 2 theta plus alpha is equal to 1. Maximum range up the plane is equal to u square by g cos square alpha into 1 minus sin alpha. We know cos square alpha is equal to 1 minus sin square alpha. Simplifying this equation, we get u square by g into 1 plus sin alpha. When the particle is projected down the plane from B at the same angle to the plane, the time of flight has the same value 2 sin theta by g cos alpha. But the component of the initial velocity along the inclined plane is u cos theta downwards. And the component acceleration g sin alpha is also downwards. Hence, range down the plane R2 is equal to u cos theta into t plus half g sin alpha into t square. Here we using the same equation 1. Next, 2u square sin theta by g cos square alpha is the common term. The remaining terms are cos theta cos alpha plus sin theta sin alpha. As we know, cos theta cos alpha plus sin theta sin alpha is equal to cos of theta minus alpha. Next, we take 2 cos of theta minus alpha into sin theta, which gives us sin of 2 theta minus alpha minus sin alpha. R2 is maximum when sin of 2 theta minus alpha is equal to 1. So maximum range down the inclined plane is equal to u square by g cos square alpha into 1 plus sin alpha. Simplifying this, we get u square by g into 1 minus sin alpha. Maximum range down the plane by maximum range up the plane is equal to u square by g into 1 minus sin alpha into g into 1 plus sin alpha by u square. Cancelling u square and g, we get 1 plus sin alpha by 1 minus sin alpha. Hence the proof. Thank you.